Hey guys, I'm a verified educator at Unacademy, and along with that, I'm also teaching live at Unacademy Plus. To access my live classes, you can take Unacademy Plus subscription. Now, Unacademy Plus offers some interesting features apart from live classes, which include detailed and complete explanation of a particular course. Then there you have problem discussion for self-evaluation. You can also watch recorded version of the class in case if you miss out any live session. You have regular doubt clearing sessions for doubt clearing and to clarify all your problems. You also get access to the WhatsApp group to clear and discuss problem among the other plus students. Now, if you have found these features interesting and want to join Unacademy Plus, I'll recommend you to use my referral code that is n_huda to get 10% discount on the subscription fee. Now that's all about Unacademy Plus. Let's continue with our video. Hello everyone and welcome to the channel. So this video is going to be about a question which was asked for 4 marks in your CSIR June 2019 exam, okay? And this particular question was from your organometallic compounds, and the basic concept asked was basically from the donor mode of NO ligand. Now, this kind of question is very frequent in your CSIR net exam. Earlier it was asked in 2017 as well, based upon the similar concept, okay? So you need to know and you need to understand this. And this question was a little bit different from the previous ones because here you need to know two things. First is the binding mode, like how NO behaves in the two different binding modes, and secondly, like how what kind of coordination complex does a particular metal forms. Okay, so being of a metal being of a certain um, transition series, how and what kind of coordination sphere does it form? Will it form a octahedral species or a tetrahedral or a square planar or a square pyramidal? So that depends. Okay, so that's what I'm going to explain in this particular video. So do watch this video very carefully. Now before starting it, the basic thing which you need to know is that NO is a ligand which can be present in two modes. One is your linear mode and the other one is bent mode. Okay, so these are two modes of binding. These are called as two binding modes of NO ligand. Now in the question it was given that you have four different complexes A, B, C, and D. These are four different complexes, and they have asked that the complex that do not exhibit bent NO coordination mode. Okay, that means they are asking about the linear mode of NO. So in which of these complexes NO is present as the linear mode? That's what they are asking generally. So how to answer this? So before answering this, you need to know that how many electron does NO ligand donates in the neutral atom method in two different modes when it binds in two different modes. So when it is present in the linear mode, it gives 3 electrons to the coordination sphere, and in the bent mode, it gives 1 electron to the coordination mode. So you need to know these things. This is very important. This is very basic thing. Okay. Now coming to the question was asked on your like let's talk about option number A first of all. So A in option number A we have iridium, Cl, and we have Co, right? And along with that we have PPH3 whole thrice, and along with that we have NO with a positive charge. And what they have asked is what kind of binding mode does this NO show? So let's first of all find out. So this can be easily done with your 18 electron rule. Okay. So before doing anything regarding 18 electron or 16 electron species, there are two general modes. 18 electron is a stable configuration or 16 electron is a stable configuration. So before going into that, you need to understand about the metal center. Now iridium over here, iridium is a metal, iridium is a metal which is a 5 which is of the 5D metal series, right? And it's present in the cobalt family. So all your 4D and 5D metal, basically when you go down the group, your metal size increases, and as the metal size increases, its ability to form square planar complexes also increase. You might have studied the thing that your 4D and 5D metal, like 4D and 5D metals generally form a square planar complex instead of forming tetrahedral complex when they are tetral, like when they are having four coordination number, right? But if you look at this complex, this iridium has a 5 coordination number, which can be easily seen. See, chlorine is a one, like all of them are the monodentate ligands. So 1, 2, and sorry, here we have 2, right? So PPH3 whole twice. Okay, so we have 1, 2.
then 3, 4, then 5. So we have 5 ligands surrounding the iridium atom. So now the best and the possible structure which this iridium can form is your square pyramidal. Okay, so iridium will form a square pyramidal geometry. That's what you need to understand. So it will look something like this: iridium forming a square pyramidal geometry. Let's bring all these ligands on the plane. So Cl is on the plane, then we have, let's say, Co is on the plane, then we have P pH3, and we have P pH3. So these are on the plane, okay, and our NO will be on the axial position. Okay, so let's say this is NO. Right now I'm not showing that what kind of binding mode it will be, like what kind of it will be, whether it will be like bent or linear, that we don't know. But yeah, this is how NO will be. Okay, so this particular square planar complex is this is, sorry, this is a square pyramidal, right? So square pyramidal geometry generally forms a 16 electron species. So this complex, instead of satisfying 18 electron rule, it has to satisfy 16 electron rule. Why is it so? Because it's a 5D metal. Iridium is in the fifth period, so it's a 5D metal. That's why uh, this is going to happen. Now let's just quickly calculate the number of valence electrons over here. So iridium will give you 9 electrons since it is in the cobalt family. Then you have 1 electron from chlorine, you have 2 electrons from this CO, that is carbonyl ligand. Then triphenyl phosphine is going to give you 2 into 2, that means 4 electrons from here. And this NO, we don't know how much electron does it NO is giving, so let's take it as X. And minus 1 because we have overall positive charge, and this should be equal to 16 as it has to follow 16 electrons rule, right? Now when you add this up, 9 plus 1 is 10, plus 6 is 16, minus 1 is 15. So X will be equal to 16 minus 15, and X will be equal to 1. That means over here NO is present as in the bent mode, not in the linear mode. Now those students who might have done the same thing, forming 18 electron rule, thought of forming this as the 18 electron species, might have done this question wrong. Okay, so it will form a 16 electron species, and NO over here will be in the bent mode. So basically in the complex, in the coordination sphere, your NO will look something like this. So N will be here. I'll just recorrect this. So N double bond O, this will be in the bent mode, and here your electrons will be. Okay, so this is how the complex will look like. So A has a bent NO. Okay, so I'm just writing bent over here. Now let's go to the second one, third one, and fourth one in the same way, and see how does NO lies in all of them. Alright, so we'll talk about option number B now. So over here again, if you see, so we have ruthenium, right? Now, if you look upon ruthenium, this also lies in the iron family, and it's a 4D metal, right? So again, the same thing will be applied over here, and the coordination number over here, if you'll see, so again, that is 1, and you have 2 more and 2 more. So 5 is the coordination number. So again, it will form a square pyramidal geometry, and the structure will be something like this: ruthenium, chlorine, then we have PPH3, then we have, let's say, uh, we have PPH3, then we have NO, right? And one NO will be on the axial position. So this is how this will be made. So if you want to check the 18 electron like whether, so what kind of species it will form, it will again form a 16 electron species, right? So let's quickly do that. So ruthenium is going to give you 8 electrons. Okay, so 8 electrons we are going to get from ruthenium, plus 1 electron from this chlorine. Then PPH3 is going to give you 2 electrons, so 2 into 2 is going to give you 4. NO, we don't know about both the NO, so let it be X and Y. Okay, because both of these NO are going to be binded. So I'm not, instead of taking 2X, I can take it as X and Y. So I'm just taking X and Y for both. One NO binding mode is taken as X, the other one is taken as Y. Minus 1 as you have a positive charge over here, and that will be equal to 16 electron, right? So if you just add this up, so 8 plus 1 is 9, plus 4 is 13, and 13 minus 1 is going to give you 12. So you are going to get 12 plus X plus Y is equals to 16, or you are going to get that X plus Y is equals to 4. Now X plus Y can be equal to 4 if either X is equals to 1 and Y is equals to 3. That is the only thing which can happen, right? both of them cannot be 2 because NO, obviously I have told you that either it can give you 1 electron or it can give you 3 electron. It can never give 2 electrons. Okay, so you cannot take 2 plus 2 is equals to 4. So remember, okay, so you cannot take 2 and 2 over here because NO does not give 2 electron. So either it can be 1 and or it can be 3. So if it is 1, that means this is in the bent mode, and if it is 3, that means it is in the linear mode. So that means what, in this particular structure, one of the NO is in bent mode and the other one is in the linear mode. So if you want to draw that properly, so that's just, let me just show you that how it will look. So this nitrogen, I'm making it as bent one, okay, and this nitrogen I'm just making it as the linear one. Okay, so this is how nitrogen in the linear mode, you have triple bond in oxygen and nitrogen in the bent mode you have double bond between nitrogen and oxygen. So this is how it is. So option number B has a bent electron, NO in the linear mode. Okay, that's what we were finding out. Now, talking about your option number C. So, option number C is going to be a little bigger molecule, because over here you have cobalt complex with NCS, that is like isothiocyanate, and diars whole twice NO. Okay, where diars is what? That is ortho Me2As whole twice C6H4. Okay, so that's what the thing is. So that means diars is nothing but, I'll just draw the structure of diars. So it's nothing but in the ortho position you have As and Me2. Okay, so you have Me2 in this position also, and at this position arsenic with Me. Okay, and this is what it is. So that's what C6H4, and at ortho position you have. So this is what diars is. Now that means this is a bidentate, right? So this is a bidentate ligand, and this is a monodentate ligand, this is also a monodentate ligand. So coordination number over here becomes 6. Now a coordination number of 6, that means, and that too a metal of your 3D metal, right? So cobalt is a 3D metal, so this is going to form a 18 electron species. So just use 18 electron rule to calculate. So from cobalt you are going to get 9 electrons. Now talking about your one of the like from the NCS you are going to get one electron, right? So from NCS you are going to get one electron, and then from your diars. So one of the diars, this arsenic is a bidentate, so two electrons from this side and two electrons from this side. So one diars is going to give you 2 plus 2, that is 4 electrons over here. Okay, so 4 into 2, so 4 electrons you are getting from one diars. How? Because arsenic is forming 3 bonds, it has 2 electrons left, so it will give 2 electrons to the coordination sphere. And because we have 2 diars, so that's a 4 into 2. Okay, and plus NO binding mode I don't know, -1 because of this positive charge. Overall we have to form 18 electron species. 9 plus 1 is 10, plus 8 is 18, -1 is 17. So we have 17 plus X is equals to 18. So X comes out to be 1, right? So X is 1. That means over here also your nitrosyl or NO is present in the bent mode. Okay, so here it is present in the bent mode, not in the um, like linear mode. If I just draw the structure of this complex, so you have CO ligand, and you have, let's say, arsenic over here. This arsenic is attached to two methyl groups, this is attached to two methyl groups, and let me just draw this. Okay, so this is how the complex will look like. These are your arsenic of diars, and they will be donating 2 electrons. So 2, 2, 2, and 2, 8 electrons will be coming from arsenic. This NO is present in the bent mode over here, giving 1 electron, and this NCS is giving you 1 electron from downside. It's a 6 coordination number complex with a 3D metal complex, so that's why it will follow 18 electron, and that's how we got that it's a bent molecule. Now taking option number D, let's solve for your option number D and see how that will be done. Now D is the our last option. Let's try to check it up. So again, it's a 3D metal complex, right? Chromium is your 3D metal complex, and your coordination number is 6. So what will be the rule followed over here? So 18 electron rule will be followed over here. So let's try to do this. 6 electrons you are going to get from chromium. Then each cyano group is going to give you 1 electron. So you are going to get 5 electrons from these cyano groups. Now NO we don't know, so let's take it as X, and then minus 3, that means you have to add 3 more over here, and overall it has to be 18, right? So 6 plus 5 is 11, plus 3 is 14. So this is going to be a 14 plus x is going to give you 18. So x is going to give you 4, right? So 4 is the requirement, but we have just one NO. So remember, now you cannot do what we have done in a previous question. What we have done in the previous question, that we were having two NO. So we have split 4 as 3 plus 1. But here we just have one NO. So we have a lot of difficulty to assign that what kind of species it will be. But what is the maximum value of x which you can attain? That means the maximum number of electrons which this NO can give. So that is 3, right? So NO can give just 3 electrons of maximum. So that means this is not a stable complex, and this one is given, this was a tricky question and was given just to check whether you have a sound knowledge of this concept or not. So instead of forming a 18 electron species, this whole complex is actually forming a 17 electron species, and it's a pretty unstable complex. Okay, and that's also shown with the charge over here, 3 minus charge. So if NO is giving 3 electrons, then how much electrons does this will have? So 6 from this chromium, 5 from this CN ligands, and you have 3 from this NO, let's say, and 3 from this charge. So that is going to give you 17 electrons. So this particular complex is a 17 electron species, not a 18 electron species, although it has to follow 18 electron rule in order to become stable. But this was tricky question. They have tried to trick you. They have given an unstable complex just to check that how you are applying your knowledge to solve this particular question. Okay, now if you are thinking that this can also solve, this can also be solved by 16 electron rule, so you are wrong over there, because for 16 electron rule your metal should be of 5D or 4D transition series. Secondly, your coordination number should be less than 6. Okay, so then only your 16 electron rule is being followed. So that means over here your NO, it should be present as a linear mode. Okay, so if I just look upon the question once again, so we can just answer out the, like, we can just find out the final answer for this question. So looking upon the options again, once again, we have seen that like we were having in the first one, we were having NO in the bent mode. In option number B, we were having in both two NO over there. One was in bent and the other one was in linear mode, right? And if you go with the option number C, so in your option number C, you were having um, in option number C, you were having NO in your bent mode, right? So it was in the bent mode, and in the last one, it was in the linear mode. So it was said in the question that the complex that do not exhibit NO, like bent NO, okay, so that do not exhibit any bent NO. So option B will also be wrong because it has bent plus linear both, right? So no bent, like which does not have any bent NO, that is only your option number D. So answer is your option C, which says D only. Okay, because you have bent plus linear in option number B, that's why we have cancelled this up, because they have said that that option or that complex which do not exhibit bent NO. So this is the only complex which do not have any bent NO. Okay, so that's your option number D, and that is going to be the correct answer for this particular question. I hope this question was quite clear. Let's take a very short question for very short and a very small question, and let's try to cover that up in the next few minutes. All right, so this was the question which was asked for 4 marks again, and this question was based upon your trans effect. Okay, so this was a very simple and a very easy question, although they tried to confuse you with the language of the question. It says that the hydrolysis of trans, this is a complex CO, L is your ligand, Cl, En whole twice plus, and where L can be your either NO2 minus or NCS minus or OH minus or Cl minus. Okay, it results in production of A. So the tendency to form cis isomer of product A follows the order. Okay, so they have given you that you have trans, this complex COL, then we have Cl, then we have En whole twice and plus, and when you are doing hydrolysis of that, so you are getting A. Okay, so we have to form cis isomer. in your A. Okay, so how you will form cis isomer from the trans product? So just try to understand this in this way, that if you have more trans effect, if you have more trans effect, that means the product which will be formed will be trans substituted product, right? That will be trans substituted product. But what is needed? We need cis isomer or cis substituted product. That means what we need? We need less trans effect in this question. So that means this question can be done on the basis of trans effect. You just have to reverse the order of the trans effect. Now, if you look upon the table for your trans effect, I will just attach that over here somewhere in on the slide in the downside. So in that you will see that I'll attach the complete trans effect table. Just take the screenshot of that. Okay, so if you look upon the trans effect series, you will find out that OH is lowest in that, OH minus is lowest in that series. Then comes your NCS minus, and then comes your uh, yeah, so then comes your Cl minus, and the highest one is your NO2 minus. Okay, so in the trans effect series, this is the order of the, like if it would have asked about the trans product, this would have been the answer. But since they have asked about the cis product, you have to just reverse this series. Okay, so the correct answer will be where your NO is least. That means in your option number B, you can, in option A and in option B both it is. So if I just reverse the order, it will be like NO2 minus will be smallest, then comes your Cl minus, then comes your NCS minus, and then comes your OH minus. So this is your option number B. So it was a clear and a easy and a direct question from your trans effect series. Okay, so I hope this was clear to you. I tried to explain two questions based upon your organometallic compounds, yet they were not asked from the usual trends. They were little like the questions were little tricky to answer. I hope this was clear to you guys, and that's all from my side, guys. Thank you so much for watching. If you like this video, do give it a like. If you're new to this channel, do subscribe to the channel and share it with your friends. So thank you so much for watching and have a great day. Bye bye.